Okay, so that's the topology which I will use for the configuration of EIGRP. So let's look at the interface status on R2, and already the basic configuration is done. So I go to enable mode and then I give a show IP interface brief command. So show IP interface brief command shows me that Ethernet 0Z0, this network or this interface, as it is on up and up status, having IP address of 172.16.2.1. Then I have a serial 00 interface which has an IP address of 172.16.3.2. This one, it is also in up and up status. Good. Serial 001, 192.168.10.9, which is that IP address here on this interface. So this is your prerequisite. This status, layer 3 status, should be up and up. So that should be confirmed and verified and configured before we start doing the EIGRP configuration. Just to make concept more clear, right now router only knows what is directly connected. The network of 172.16.2.0, router and 172.16.3.0 and 192.168.10.8 network, because these are the directly connected networks. Now once we will do the EIGRP configuration, it should know, and that's why we are doing this EIGRP configuration, that the remote networks 1.0, 10.4 network and 16.1.0 network, that should also be known to the router too. So right now let's see what is the status of routing table. Show IP route. See, it knows 2.0 network, it has information about 3.0 network, and it has information about 10.8 network. So no remote network is there. Similar is the status of R1 and R3. Okay, so that's verified, everything is okay. Layer 3 serial connection, that is fine. Now if these connections are not working, R1 is not able to ping from here to here, we need to troubleshoot that first before we start configuring the EIGRP. But in our case, it's okay. So let's go to R1 and then configure EIGRP. So global configuration mode, conf t, and we use a command which is called router EIGRP. And then after that, it's autonomous system number. Now what is it? So autonomous system is a collection of networks which are under the control of a single authority. So one organization which is taking and having a control of all those routers, the whole network, that is allocated with a one number. And this number, AS number, is managed by INA, International Authority for the Assigned Numbering. And it is assigned to RIRs and then regional internet registries, and then ultimately it goes to the service provider. Okay, so that's the AS number. So usually it's a 16-bit numbers, but ranging from 0 to 65,535. And now since 2007, that number is the number of bits have been increased now to 32 bits. So now it is we can have AS numbers to over 4 billions. Okay, so let's get back to our R1, and so I'll go to enable mode, conf terminal, global configuration mode, and now routing protocol configuration mode, router, and then I'll use EIGRP. And if you put question mark, it asks me autonomous system number. So just for ease, I'll choose, of course, as when you are working in industry, you have to get it from your service provider. But over here, I'm using, say, 10. All right. And then after that, I will use a command which is called network command. Now, network command enables EIGRP on that network, or we should say that on that interface, which is directly connected to the router. So first of all, I will enable it on this one, 172.16.1.0. So network, and if you put question mark, tells you put the network number. So it is 172.16.1.0. Now that's the mask value is /24. Okay, so what we're going to do, we will use the wildcard mask. So it's an invert of the mask value, which we can calculate using 255, 255, 255, and 255 number, and subtract the decimal notation of your mask. So that will give me 0.0.0.255. So that's a wildcard mask for /24. And then the next network command, in this network, the second network which I will include in my EIGRP is .3.0. It has a mask value of /30. So wildcard mask of /30 is 0.0.0.3. Third directly connected network is 192.168.10.4. So network 192.168.10.4, and it has a mask value of /30. So wildcard mask will be 0.0.0.3. Enter. So this is how we configure of EIGRP on our router. So I've done it on R1. I will also do it on R2 and R3. So all three routers must be configured with EIGRP. So I'll go to R2, enable conf terminal, router, EIGRP. Now autonomous system number will remain same. Be careful about that. So we have used 10, and then network commands, network 172.16.3.0. So this is your first serial 00 network. It is using /30 as the mask value. So wildcard mask will be 0.0.0.3. And you can see straight away, because it's already configured here, straight away it is finding that neighbor 13.1 and new adjacency is created. So after exchange of hello, they create adjacency. Now next network is 172.16.2.0, which is the LAN network, 0.0.255. Next network is 192.168.10.8 network. network, and it has a /30, so 0.0.0.3. That's it. So that's your R2 configuration. All right, so let's jump to R3 now. Enable mode, global configuration mode, and router configuration, router EIGRP, again 10, and then say network. And on R3, so let's start with 10.8. So 192.168.10.8, and the wildcard mask 0.0.0.3. And you see straight away adjacency is created. Next network is 192.168.10.4. Wildcard mask is 00003. And straight away another adjacency is created. Next is 192.168 1.0 network. And it has a wildcard mask of 0000255. Enter. So this is how we configure EIGRP. So configuration is done. Now there are some commands which are available for the verification. Of course, the first verification command is look at the routing table. So if I'm on R3, so R3 should be able to see 16.2.0 network, 16.3.0 network, and 1.0 network, and that should be in the routing table of the R3. So show IP route and enter. Here we go. Good. So the first column shows the protocol code. With the help of that protocol, we have learned this network. So this D shows that it is the EIGRP protocol at the top of the routing table. You can see that code as well. 172.16.1.0 network, which is that one. So it has learned with the help of EIGRP routing protocol, and we can get from R3 to 16.1.0 network via 192.168.10.5. which is that IP address, sorry, that next hop IP address, 10.5 of R1. You're using local serial 000 as the exiting interface. And it has a cost of 2170112. It's a big value, it's a big number. So I will explain in our next lecture that how it is calculated. It uses a formula based on bandwidth and delay and some other parameters. 90 is the administrative distance of EIGRP. It's a default value. It's a trustworthiness of a routing protocol. EIGRP default AD value is 90. Then you see that we have another network is LUNT 2.0, which is that one, with the help of EIGRP routing protocol, and we can get there via 10.9, which is their IP address on R2, next hop IP address, using serial 001 as the exiting interface. It has a cost value of 2170112, also an AD value. The third network is interesting. Interesting in a sense that there are two paths available. So 3.0 network is here. It's a middle network. I can go via that direction, and also from here, that direction. So that's why you see there are two paths are available. They both have equal cost. That's why they are listed in the routing table. And you see that it is, the first path is via 10.9, which is that next hop IP address of router 2. And the other path is 10.5, which is that IP address of the router 1. And they both are equal cost. And that is the default behavior of EIGRP, that if there are two equal cost paths available, then load balancing is done by default. So what will happen? One packet will go via that way and the other one will go that way. Default load balancing. So these are the three networks, and you can see that this router 3 can see, it already was able to see directly connected networks 1.0, 10.8 and 10.4, and now with the help of EIGRP it can see 1.0 network, remote network, 2.0 network, remote, and 3.0. And now if I try to ping from here, another verification, ping, say I try to ping 172.16.1.1 IP address over here, which is on R1 LAN, so 172.16.1.1. See, I'm getting a ping. So I'm getting all the way from here to here and back. So this is another verification that my routing is okay. For further verification, I can go to R2 and see show IP route routing table, and the same story is here. It is learning its remote network D, D, and D. And over here, another the same situation is that this network, there are two ways to go, two paths available on 10.4, and you see two paths are mentioned. Similar will be the case with R1, because for R1 the two paths are available to get to 10.8 network, this one, and show IP route. So now you can see that 2.0 network and 1.0, oh sorry, 10. For R1, yeah, sorry, 10.8 networks. 10.8 network, this one. It has two ways, two paths available. One is via 3.2, this one, and the other one is 10.6, this one. Another verification command for EIGRP is show IP protocols. This is not only used for verification but also for troubleshooting purposes as well. So sometimes what happens that when we are putting network commands, we might miss some of the networks which are directly connected networks. So we can confirm from here. Yeah. EIGRP 10. Okay. EIGRP 10. Autonomous system number is 10. And okay. So it is, so these three networks are there which are included into our EIGRP process. 1.0, that one, 10.4 and 3.0. So we can verify from here also. Router ID is the ID of the router, and it is chosen by this router in IPV4, EIGRP for IPV4. If we don't assign a router ID, it is chosen by router itself, and it is the interface, highest active interface address. Okay, so let's give this same command on router 2 as well, show IP protocols. Yep. So that's what the verification and configuration of our EIGRP, and that's the Packet Tracer Lab configuration of basic EIGRP with IPV4. Thanks.